Welcome to solverfy.
All right, so we're going to draw some structures and then determine if they're optically active. Starting with A, we've got 1,3-dichloropentane. So starting with just drawing my pentane. And then we're going to add to the 1 and the 3 carbon. So that's the 1. This will be 3-dichloropentane. Okay. So now we need to determine if this is optically active. The answer is going to be yes, because this is going to be a chiral center. The reason it's a chiral center is because it's bonded to 4 groups, the first being a chlorine, then a hydrogen, an ethyl, and then a chlorinated ethyl. So since this chlorine is there, that distinguishes that ethyl group from the other, thus making this optically active. All right, moving on to B, which we have 3-chloro 2,2,5-trimethylhexane. So starting with just the hexane part. All right, we're going to start with the, I'm going to start by just drawing the ethyls first, having 2,2,5. So I'm going to have 2, 2, 5 ethyls, and then 3-chloro. So this will be a chloro right here. Okay, so now we need to determine if there's any chiral centers in here and if this whole molecule is optically active. And you can see that this center right here, or this carbon right there, is going to be a chiral center. And the reason for that is it's bonded to a chlorine, a hydrogen, and then 2 very different carbon chains. All right, and then lastly, we have got 1-bromo, 1-chlorobutane. So starting with my butane, I'm going to draw 1-chloro, 1-bromo like that. Now, obviously that makes this a chiral center right here because that's bonded to a bromine, a chlorine, a hydrogen, and a carbon chain. So that molecule is very obviously optically active.